Okay, in this video I'm going to show you how to solve nonlinear systems of equations by graphing. Nonlinear systems of equations refers to we have functions or equations that are not linear. For example, quadratic functions, circles, hyperbolas, and other kind of functions. In this case, our example here is asking us to solve or figure out when f of x equals g of x when both f and g are quadratic equations. Now keep in mind what this could mean. If we have two parabolas and we're trying to figure out when they are equal to each other, we have possibly two or three different cases here. If we have a parabola that is the same as the other one, then there's infinitely many solutions. But obviously these two parabolas are not the same. You could tell right away. You could have a parabola and another parabola, and they intersect in two places. So we could have two solutions. And then we could have a parabola, and we could have a parabola that only crosses it exactly one time when they are equal exactly 1 point. So we could have one solution. And well, what is the other case? The other case is if we have two parabolas that don't intersect each other. For example, one faces up, the other one faces down, but they don't intersect at all. So there's no, in this case, it would be no intersection. That means no solution. Okay, so it's good to know, it's good to have an idea on what are the possibilities when we're solving an equation like this, or a system of equations like this. So let's see which one that is. Now, if you know how to do this by hand, it's probably not gonna ask you to solve a system like this by hand, because it's pretty you have to be very accurate to figure out what the solution is. Because we're solving by graphing, let's go ahead and go to Desmos. Just go to desmos.com and notice how I already have my first equation typed. You don't have to type the f and the g when you're solving equations like this. If you do, it'll still graph it, it'll give you the same answer. So I'm going to go ahead and type in my second equation, which is negative x squared minus 3x plus 16. And notice how these two graphs are intersecting in two different places. So the three or four cases that we had that I explained before, in this case in our graph, you can see that these two graphs only intersect at two places, and all we have to do is click where they intersect, and that'll give us the x. We're not interested in the y. We are interested in the x. When or what values of x do the two functions intersect or are equivalent? In this case, our answers are x equals -5 and x equals 2. So keep that in mind, keep that graph in mind. All you have to do is go back to your question and answer here is the solution. Our solution here is going to be okay. So we could say, the answer here is whenever x equals -5 or whenever x equals 2, and these two functions are the same. Notice again, you could check this algebraically. You don't have to, but if you are taking a test or an important test and you want to make sure you got it right, notice what f of -5 is. -5 squared plus 3 times -5 minus 4. This is 25. -5 squared is 25. 3 times -5 makes -15, and minus 4. 10 minus 4 is 6. So f of -5 is 6. Since we know we got this equation right, this answer right, when we substitute -5 into g, we're going to see that they are actually the same at that point. So this is -5 squared, which is 25, but there's a negative outside, so it's a -25 plus 15 plus 16. Well, -25 negative 25 and 15 makes negative 10, and negative 10 plus 16 happens to be exactly 6. So that shows us that at least the first solution is correct. We could do the same thing to check x equals 2, but that's just checking algebraically. Okay, so again, all of this work could be done for you, or you should be able to do it on Desmos and be able to answer your question like this. X equals negative 5 and x equals 2 right here. X equals negative 5 and x equals 2. Okay, I hope this video helps you in maybe learning or reviewing something of this nature. Please consider, the different types of equations that we could have. We could have a line, we could have parabolas, circles, and figure out what these are equivalent. Okay, please keep reviewing, keep doing math, and see you next time.